In part 5 of our lesson on the inverse circular functions, we will explore the graphs of cotangent inverse, secant inverse, and cosecant inverse. First up, we have y equals cotangent inverse of x. You can see there's a horizontal asymptote at y equals 0. There's also a horizontal asymptote at y equals pi. The domain of the graph, we can see that the x values go forever in the negative direction and forever in the positive direction. So the domain is going to be negative infinity to positive infinity. The range is going from 0 to pi, and we have to exclude those endpoint values because they are horizontal asymptotes. So the range will be 0 to pi with the soft brackets. Next up, we have y equals the secant inverse of x. And this is the entire graph. You can see there is a horizontal asymptote here at y equals pi over 2. Now the x values go forever in the negative infinity direction, but notice they only go up to this x value, which is -1. Then the graph does not exist between -1 and 1. And the x values start up again at 1 and then go forever in the positive infinity direction. So the domain is negative infinity to -1 union 1 to positive infinity. And notice these are hard brackets, both of these, because the x value can equal -1 and it can equal +1. Now, let's take a look at this range. It starts at 0, that's the smallest y value, and then it gets infinitely close to pi over 2, but it can't quite get there because of that asymptote. So the range is going to be 0 to pi over 2 union. Now notice there's a hard bracket on the 0 because 0 is included. Soft bracket on the pi over 2 because the pi over 2 is excluded due to the asymptote. Now for this upper part, we can see that it goes from pi over 2 to pi, but the pi over 2 once again has to be excluded, and the pi is included because it actually attains that y value of pi. Finally, we have the graph of y equals cosecant inverse of x. And notice there is a horizontal asymptote here at y equals 0. The x values go forever in the negative infinity direction, but similarly to secant inverse, they stop at x equals -1. So the domain is going to be in two pieces again, from negative infinity to -1, and it includes that -1, union, the x values start up again at 1 and go off to positive infinity. So the function does not exist at all in between -1 and 1. The range, the smallest y value is -pi over 2, and it does attain that value, so we put a hard bracket on the negative pi over 2. And then you can see the y values increase until they get to 0, but they can never equal 0 because it's an asymptote. So we have to put an open bracket on the 0. Union. We'll start back up at 0 again, but have to exclude it because of the asymptote. And then the y values will go up until it gets to pi over 2, which is included, so we put a hard bracket there. Next, we're going to make a summary of the ranges of the inverse trig functions, and we're going to put that summary on the unit circle. Now, throughout this lesson, we've been working with the graphs in the xy plane, but for the purposes of this summary, I think it's really convenient to use the unit circle. So let's start off by looking at the graph of y equals sine inverse of x. We see that the range of that graph is negative pi over 2 to positive pi over 2. Now on the unit circle, we know that negative pi over 2 is down here, and 0 would be here, and positive pi over 2 would be here. So if we transfer the range of the sine inverse function and think of it as angles on the unit circle, then the angles that get output from sine inverse are going to be from quadrant 4, starting at negative pi over 2, going through 0, and then going into quadrant 1 to positive pi over 2. Looking at the graph of cosine inverse of x, we discovered that its range was from 0 to pi. So if we transfer that from the xy plane and put it on the unit circle, we know 0 is here, pi is over here. So cosine inverse is always going to give us either a quadrant 1 angle or a quadrant 2 angle when we're looking on the unit circle. Looking at the graph of y equals tangent inverse of x, we discovered that the range was negative pi over 2 to positive pi over 2, non-inclusive, so we can't include those endpoints. But looking at the unit circle, that means it goes from negative pi over 2 up to positive pi over 2. So it's essentially in the same two quadrants as sine inverse was. Now let's look at the cotangent inverse graph, and we see that its range is from 0 to pi, non-inclusive because of those asymptotes there. And if we transfer that to the unit circle, we know it's going to go from 0 to pi, so it will be in quadrants 1 and 2, just like cosine inverse. So cotangent inverse of a positive will be here, and of a negative will be here in quadrant 2. Looking at the graph of secant inverse, we see that its range was 0 to pi over 2, union pi over 2 to pi. So that's essentially quadrant 1 and quadrant 2. So from 0 to pi, secant inverse of a positive will be here in quadrant 1, secant inverse of a negative will be here in quadrant 2. And finally, looking at the graph of cosecant inverse, its range was from negative pi over 2 to 0, union 0 to pi over 2. Transferring that to the unit circle, we see that it lives in the same two quadrants as sine inverse and tangent inverse. So the 6 inverse trig functions come in two flavors, either 0 to pi and that's cosine inverse, cotangent inverse, and secant inverse, or negative pi over 2 to positive pi over 2, which is sine inverse, tangent inverse, and cosecant inverse. Now let's put this summary chart to work in this example where we have to give each exact value. It's CYU time, so pause the video, work the example on your own, then restart the video to check your answer. Okay, let's see how you did. We start with the sine inverse of negative radical 2 over 2. And you know that you can rewrite that as sine of theta has to equal negative radical 2 over 2. Now, if you're taking the sine inverse of something, you know that sine inverse lives between negative pi over 2 and positive pi over 2. And since we're taking the sine inverse of a negative, we know we have to be down here in quadrant 4, and our answer has to be between negative pi over 2 and 0. The only answer in that interval, whose sine is negative radical 2 over 2, is negative pi over 4. Now let's compare that to the cosine inverse of negative radical 2 over 2. Cosine inverse lives between 0 and pi. So we have to think of an angle where the cosine of that angle has to be negative radical 2 over 2. Now, because it's the cosine inverse of a negative, that means we're going to be over here in quadrant 2. Our answer is going to have to be between pi over 2 and pi. The only angle in quadrant 2 that would satisfy cosine theta has to equal negative radical 2 over 2 is 3 pi over 4. And just a quick reminder, cosine inverse can never give a negative answer because the range of cosine inverse is from 0 to pi. All the angles that are output from the cosine inverse function must be positive, and they will be in either quadrant 1 or quadrant 2. Let's take a look at the tangent inverse of negative 1. We know we are thinking of an angle such that the tangent of that angle has to equal negative 1. We know that tangent inverse lives between negative pi over 2 and positive pi over 2. Since it's the tangent inverse of a negative, that means it's got to be down here in quadrant 4 between negative pi over 2 and 0. The only angle in that region whose tangent is negative 1 is negative pi over 4. This next one is cotangent inverse of negative 1. Cotangent inverse lives from 0 to pi. The cotangent inverse of a negative has to be in quadrant 2. So what you're thinking is the cotangent of some angle has to be negative 1, and that angle has to be between pi over 2 and pi because that's where the cotangent inverse of a negative lives. And the only angle in that region would be 3 pi over 4. Next up, we have the secant inverse of -2. So we know we have to think of an angle such that secant of theta is -2. Now, secant inverse lives here, so it lives between 0 and pi. Secant inverse of a negative is over here. We know our answer will be between pi over 2 and pi. Now, sometimes it's easier for us to think in terms of the cosine instead of the secant. So if secant theta is -2, you can think of it as cosine theta is -half. We know that the only angle over here in quadrant 2 whose cosine would be -1/2 is 2 pi over 3. Now let's see how that compares to the cosecant inverse of -2. Cosecant inverse lives here in quadrant 1 and here in quadrant 4. So it lives between -pi over 2 and +pi over 2. Since it's the cosecant inverse of a negative, we know we're going to have to be down here in quadrant 4 between -pi over 2 and 0. So we have to think of an angle such that the cosecant of that angle is equal to -2, or we can think of it as the sine of that angle is equal to -1/2. Down here in quadrant 4, between -pi over 2 and 0, the only angle whose sine would be -1/2 is -pi over 6. Now let me draw your attention to something here. When you're thinking in terms of the cotangent inverse, you might be tempted to switch it to tangent inverse, and you can do that, but you have to be very careful when you do, because notice that cotangent inverse lives in different quadrants than tangent inverse lives in. Let's say, for example, that you took this problem, the cotangent inverse of -1, which we know means we can think of it as cotangent theta equals -1, or maybe you decided to think of it as tangent of theta equals 1 over -1, which is also -1. Now you have to be careful here, because if you're doing tangent is -1, if you're using the tangent inverse, your answer would have been -pi over 4 down here. So you could use that as a reference angle of some sort, if you will, but you have to remember that your original problem was cotangent inverse, so you would have to take that -pi over 4 and put it over here in quadrant 2 to get 3 pi over 4 because it's cotangent inverse. So you can use that, but you just have to be very, very careful and remember where each of the trig functions lives. Now, if you think physically about this, -pi over 4 is here. We know the answer has to be 3 pi over 4. So from -pi over 4, you would add pi to end up at 3 pi over 4. And that's if you are switching between tangent inverse and cotangent inverse of negatives.